Hello, in this video I'm going to share with you the two possible configurations that the 5 timer can be worked with. These are the monostable and the bistable. I'm going to make practical circuit on the breadboard for us to utilize these modes, the monostable and the bistable. I'll explain more on it later. Now this is my breadboard and I'm going to breadboard the bistable circuit first for us to see the practical version of it and also explain a little of how it works. In my case, I am using touch switches as to replace push buttons because that is what I have at hand at the moment. And lastly, the LED. Based on the schematic I showed, this is how it has been connected in the breadboard also. This touch sensor is connected to the trigger, which will turn on the LED, and this sensor is connected to the reset, which will turn on the LED succeedingly. So now this is my first breadboarding after drawing the diagram. So let me run the first test. Switch on the power supply. See, there is possibly some wiring error because the bulb comes on even when we have not really done anything. Okay, everything is pretty much done. I just saw that I didn't connect the threshold of the 555 timer to the ground pin, and there was also some wiring error in the touch sensors. So all those have been dealt with. So let's give it a try. See, this is the reset sensor, and as I touched it, the red LED comes on. If I touch this is the trigger, I'm sorry, this is the trigger. And if I touch this, it goes off. Comes on, goes off. So this is an example of a bistable mode of the 555 timer. You can use this in many types of circuits which I will deal with in the future. For now, this is just the basic operation of a timer. Now let's go over the monostable configuration. This is how the monostable configuration looks like on my breadboard. A very simple circuit with only one touch sensor for turning on the LED. Now I've connected my resistors in the order to keep the LED on for 5 seconds after the switch has been touched and turns the LED off. So it works like this for 5 seconds and it goes off. For 5 seconds and it goes off. I'll give you more details on how the circuits work. Stay tuned. As you can see in my practical examples, touching the trigger switch allows the current to flow from VCC to ground. Now, which causes the voltage at the trigger to drop. When the trigger pin of the IC is at a lower voltage, the output gets switched on and the LED lights up. If the output stage stays on until the voltage at the threshold is 2/3 of the VCC, the output goes low. But as long as the threshold is grounded and not able to rise up to 2/3 VCC, the output will remain high. Now, if the reset sensor or switch is now touched, the voltage at the reset goes to 0, which means it is pulled down to 0. Then the pin goes low. When the reset pin goes low, the output is switched off. And that is basically how an unstable circuit or the 555 timer work. Initially, when the IC is powered, the trigger pin is high and the discharge pin connects the capacitor to ground, preventing it from charging up through R1. Now, when this trigger sensor or the trigger button is pressed or touched, the output goes high and the discharge pin connects the capacitor to VCC through R1 so that it can start charging up. Now, after a while, after the capacitor has been charged to 2/3 of the VCC, the threshold detects this 2/3 voltage and makes the output to go low. Now, while at the same time, the discharge pin connects the capacitor back to ground to prevent it from charging up until the switch is touched again. Now, the duration at which the LED will stay on after the switch has been touched matters on the amount of period or the time the capacitor takes to charge to 2/3 VCC of the power supply. I hope you understand and enjoyed this video. In case you have enjoyed this video and have learned something new, please like and subscribe to this channel and stay updated for more videos like this.